How to calculate the fresh air or outdoor airflow requirement at the breathing zone. So we are looking for VBZ. Outdoor airflow requirement has been represented by this VBZ. Okay, the equation is in here. Very short equation. Let me make you familiarize with this equation and explain how to use this. It is quite simple actually. For instance, if you come to this table, at the first column, we get the type of facility. So the table is actually very long. For instance, let's say we are calculating like in the animal operating rooms. This is our facility. Then in the second column, we get the people out there requirement. For instance, how much air is required per person. For instance, at the animal room, CFM per person is given here. 10 CFM per person is required. If you are comfortable with SI unit, you can use liter per second. It is also provided here, 5 liter per second. Okay. And at the outdoor air rate, area outdoor air rate, this is RA. This is provided in square feet. For instance, in IP unit, CFM per square feet. For this certain facility, it is 0.18 CFM per square feet. And if you want to find out it in the liter per second SI unit, you get 0.9 here. Okay. So what are this value? For instance, to find out the required outdoor air flow rate, we need two more informations. Number one, occupancy number. The occupancy number is represented by PZ here. So people, let's say there are about 20 people inside. And secondly, you need to know the area. Area, the symbol is AZ. Let's say the area is 1000 square feet. Okay. Now, if you apply this formula, from here we get RP is equal to 10 CFM per person and RA is equal to 0.18 CFM per SFT. Now, I think you already got how to do next. It's very simple. BBZ is equal to, we know RP is 10, number of people is 20. So 10 multiply with the 20, 200 CFM here, plus RA is 0.18, yes. So 0.18 multiply with 1000. Now, if you solve this, you get the amount of fresh air. Again, this is not the end of the story. You also have to consider the way you are introducing fresh air inside the facility. For instance, floor supply of warm air and floor return. If you supply in the floor supply with the warm and floor return, floor supply the warm air and the ceiling return, the way you are delivering the fresh air in the facility will impact the effectiveness. If the effectiveness is low, for instance, let's say the way you are delivering the makeup for air, a supply outlet located less than half length of the space from the exhaust return or both. In this scenario, the air distribution effectiveness is 0.5. Then again, you have to recalculate this. You have to find the VBZ and divide it by EZ. Let's look at a sample calculation. Will clear you up the concept totally.